This is the 39th Reference Tooling Workgroup meeting. We had a slight issue at the very beginning of the recording. You haven't really missed much in that while we don't talk it through, the topic of conversation is what you will see displayed on the first slide. Thank you for being here, and I look forward to seeing you soon.
Besides that, you probably have also recognized Chain's email that the SPDX specification will be released very soon. I think in August, or it's planned in August to have it as an ISO standard. And yeah, then I think this is a second major milestone besides the OpenChain ISO specification.
Just so you know, we began recording about 10 seconds ago.
Okay, cool. Are there any further news you want to share with the group?
Unmuted.
Oh yeah, just really that the interoperability push will be something big. I'm planning to invest a lot of time and some capital into a large case study about interoperability hung on SPDX, because that's where we have a lot of attention with the press and so on. And if you're a tool maintainer or you're someone using a tool who can work with me on aspects of this case study, that would be fantastic, because we're going to be reaching a global audience. And we can, I think, move the needle on making open source to open source tooling interoperability better, and also encouraging all of our acquaintances and friends at proprietary tooling organizations to do the same.
That sounds very interesting. And when do you have planned this, or
okay, so I've just
what's the
it's a good question. I've just begun talking about it, at the the OpenChain board meeting recently. We just had everyone say that they want to see something substantial happen with a case study around interoperability. And I've just been getting ready to put time in there as soon as I knew an SPDX was ready to publish. I'd love to have the first parts of the case study out in middle August onwards, and then on a rolling basis, release aspects of the interoperability case study as we go.
Cool. So I will be very interested in supporting you.
Excellent, excellent. I'll follow up with everyone by email to the list. And basically, I think this might be our biggest chance in the last 5 or so years to change minds.
So, since we're on SPDX land, work for SPDX 3 is proceeding regularly. And we have really great discussions about what's the scope, right? Because the version 3 that is being designed right now, first of all, is, okay, you've heard me before, it's modular and more extensible, stuff like that, right? But the idea is to cover something more than software, right? So the idea is that it should be able to produce a BOM, but definitely, software as BOM is one of the first use cases that we're talking about, and we really discussing whether it's only for exchange or also for information, and yeah, this might affect the whole thing. So, for example, we're still debating whether, if you know the SPDX nomenclature and all the definitions, whether a document is something central, or you can just have information about different components and call them SPDX or whatever. And yeah, we're still working on that.
Oh, I got something. I got something. Sorry, guys. There was just a message from Renault on the OpenChain Slack, where basically they were inquiring how to use SPDX, and there was some misconceptions about SPDX only being file level and not a full SBOM. And I've begun to discuss this with the people from Renault, but it might be something cool for some of you to go and help out with, because it's an example of how we have some really nice stuff happening, where we can help, I suppose, help shape people, their understanding. So I'm going to put the link in the chat, just in case you want it.
Yep, cool, thank you. Further news?
One brief thing, in case people haven't heard, the to-do group at Linux Foundation have a presentation next week on how to start an OSPO program.
Oh no, I wasn't aware of that. Have you a link for that?
Just posted.
Oh,
oh,
cool. Great,
lovely.
Muted.
Further news? Obviously, this is not the case. Then...
Sorry, Oliver. Shane, do you want to say something about the security extension on the OpenChain spec?
Okie dokie, absolutely. So in the OpenChain specification, we're in the final run of having a security extension, which is actually a reference guide. It's not about changing the OpenChain ISO standard. I've just posted a link to the editable document. It's right there now in our chat. Long story short, people are using people are using OpenChain for security. And to address this, we have looked at the spec, chopped out the bits that aren't related to security, tweaked a few words, and provided this reference document, which is keyed for publication in 2 weeks, so that people can take our ISO standard for compliance and apply it to security in a consistent manner. Reasoning is, people are already doing this. We don't really want the supply chain to get ad hoc with how they apply OpenChain to security, so this guidance document will hopefully help people. Like I said, it is not changing the ISO standard, but it's allowing you to place the security optic on the ISO standard. This won't relate immediately to tooling, except for the fact that we can expect OpenChain to continue to expand in security, and therefore we can expect SPDX, and therefore we can expect the tooling to continually head in that direction.
Muted.
Thank you, Shane. Further news? No, then let's move to our next agenda item, which is the presentation from Martin and Mikko.
Hello everyone, this is Martin here. Mikko, will you share the screen or will I?
I can do it. Sure.
Thanks. So I will end my screen sharing.
So I think, hello everyone, I'm Martin from Villebranta. I think I've met many of you in a number of occasions, but obviously not all. We will be doing so that Mikko will present the double open approach, and he'll also present himself there shortly, and I'll have some, in a way, towards the end I'll have some additional comments there. So thank you, Oliver, very much for the chance to discuss this here. So Mikko, please, from my
yeah, I'm trying to find. Are there any tips how to share the screen? I can't seem to find.
So there's a plus sign.
Yeah.
And there it's usually set to be a presenter, and then you only have to click on this. And I see that you have already the presenter icon.
Oh, it's yeah. Now I've found. Great, thank you.
You're welcome.
Great. And everyone should see my screen right now, right?
Yes.
Yeah, great. So nice to meet you all. My name is Mikko Murto. We're going to talk about this, how we at Double Open Project have been approaching this automated open source compliance for Yocto build system. Short introduction. So my name is Mikko Murto. I'm a lawyer at HH Partners Attorneys at Law, and also the developer at Double Open Project. And Martin, do you want to introduce yourself?
Yeah. So thanks, Mikko. So I'm a partner at HH Partners. I've been also. Many know me as a chairman of the Validus initiative. That's a Finnish initiative for doing openness compliance for a group of companies. And really the background of the Double Open project is in a way in that Validus work and some of the, in a way, it's run for 13 years and it's some of the working methods there became outdated, and this Double Open project is one way to. One reason for this project is to address those. The other reasons, more general, to automate the work that we see is very human intensive if you want to do it well. So Mikko will explain more on that. So please go on.
Yeah, thank you. So just a short background on the kind of this tooling aspect of Double Open Project. So we are part of this Double Open Project that is kind of divided into, there's this tooling project and competence development project. And for the tooling project, we're focusing on automating license compliance for Yocto builds. For those who may not be aware of Yocto or familiar with Yocto is a build system is used to build embedded Linux images or kind of Linux builds, and we're currently working on this proof of concept for using our Double Open workflow and with a company that uses Yocto for their embedded needs. We've tried to be as modular as possible to make supporting other build systems kind of possible later. But currently we're focusing on Yocto to get it working from start to finish. So here are some goals that we've set for this proof of concept project that we're doing for this tooling part. One of the first goals is to use SPDX as the data format. That is mainly to kind of enable this interoperability with other tools. So if someone wanted to use maybe only the first part to get the kind of raw SPDX file from Yocto, then and utilize that SPDX with other SPDX supporting tools, that could be possible. So we find SPDX to be very, very good here to, or at least hope that it enables a lot of interoperability. To do any kind of compliance work, of course, one of the main or the beginning is to analyze the software project. So we have to create a detailed bill of materials of the Yocto build or the image that Yocto builds, and after we have that raw SPDX information, we need to get license and copyright information for that. And for this proof of concept, we're working with Fossology for the license and copyright information, as that's very familiar to us. And after we have depopulated SPDX with license and copyright information, we're using OSS Review toolkit to evaluate the project against some license policy. And then we create reports and notice files also with OSS Review Toolkit. And one of the goals of this project has also been to create a workflow to support this as a part of continuous integration pipelines to keep compliance up to date. Kind of an ancillary goal, but very important also, has been to store all the relevant data that we can for vulnerability management in the process. So those are kind of the general goals for the proof of concept with the tooling project. So now I'll go a little bit deeper on what we do with kind of the different steps. So how the workflow works from beginning to the end. So as said, the first step is, of course, to create the kind of get all the necessary data out of the Yocto build or the image that has been built. For that, we create the SPDX, a bill of materials in SPDX format during the Yocto build. And this is done what in Yocto is called meta layers, or they are kind of these things that you can attach to your build. They're kind of additional recipes that are run during the build. So when you add our meta layer, meta double open to the Yocto build, in addition to the image, you'll get the SPDX that tries to represent the image as close as possible and all the information that we can retrieve during the build. So what information we are storing there? The first is, of course, that we want to determine all the packages that are packaged with the image that are actually shipped. Yocto builds a lot of stuff during the build, all of which is not actually included in the image. So it kind of builds building tools and the development tools that are not always included. So we try to filter those away. And for each package, we store all the information, kind of what binary files were built for this image and what binary files of this image were actually included. What binary files of package were included in this image. And for all those binary files, we use this debug utility to pinpoint all the source files that were actually used to build those individual binary files. So the kind of data tree goes something like we have packages which have binary files which correspond to their source files. We also store CPE IDs of the packages that are built and included in the images. And then one head scratcher here was that Yocto, it has this system that even though the version number may say that some package or CPE ID is targeted by some CVEs, Yocto may patch these during the build, which is not really mirrored in the version number. So we also save information about the CVEs that have, according to the build system, been fixed during the build. And all of this data we store in SPDX document. And as I said, to enable interoperability, so you could only use this meta double open layer if you need SPDX from Yocto. And we've had very good support from Yocto developers, and they've taken quite good interest in this, and there have been some discussions that as more and more build systems are kind of interested in creating bill of materials natively. So there's been some discussions that something based on this could be included in the core Yocto or core Open Embedded. So that's what some Yocto developers have been working and are working now. And there's the GitHub page for where the meta layer is currently found. And by the way, if there's any questions at any point, no need to wait till the end. So just say something to the microphone. Yeah. So now after this first step, we have this raw SPDX, including information about the packages and files and whatever was packaged into the image. We identify the files by their hash values. So now we, of course, need to populate the SPDX file with some license information. And for this, we currently use Fossology. So of course, we have to get the packages or the source of the packages in Fossology. So we upload them with a tool, and then the unclear scanner findings can be curated in Fossology, and we try to use Fossology's tooling to enable us to kind of reuse all of the old curations. And so manual work should only be done once, if possible. After we have the data in Fossology, we then query the information from Fossology's REST API and store it back in the SPDX document. So we get the scanner hits from Fossology, and then also the human curations from Fossology, and store them in relevant fields in the SPDX document for individual files and populate it there. And then now we have in previous step we had this raw SPDX without any license information, only no assertions, and now we have kind of per file level license information and copyright information. So what would we do with that populated SPDX document? We started building our own kind of evaluation tool, but then after some good feedback, we decided to start using OS Review Toolkit's evaluator and reporter also for this, as we've used it for other projects also. But as many of you probably know, ORT doesn't really support SPDX input in its current form. So we built this SPDX to ORT conversion. So it takes SPDX document in the format that we've, or kind of with the conventions that we've used for our meta layer, and they converts it to ORT's result document. So kind of mimics ORT's scanner result that we can then use to run evaluator and reporter later on. And I think many of you are familiar with OS Review Toolkit, but the kind of evaluation is based on these license classifications and some rules based on those. And this usage of ORT also brings the reporter for us, which allows us to create these reports in very many different formats, like these notice files and web app and Excel, if that's someone's thing. This policy thing is something that we've been kind of working on lately also. So how do we categorize licenses? And we've kind of now settled into this categorization based on these license categories, like permissive or copyleft strong or commercial license. And then we also add these license properties like network clause or nuclear restrictions, also rules for ORT's evaluator that can then be written for different use cases. We also kind of due to this our tooling that using Fossology to generate these scanner results, and then also using that to conclude the licensing information. There we use some ORT key features here, like resolutions and of course reporting, but then others like exclusions should be handled by the kind of filtering by the binary to source code linking, and then we use the Fossology to do the license finding curation part also. For our policy, we've decided to kind of allow interoperability better between tools. We've decided to use, of course, SPDX license naming, and also stick with the naming that ScanCode uses. Even though we're not currently using ScanCode in this proof of concept project, we decided that it's good to kind of, they have quite extensive list of licenses that they've named, so we decided to use it so it's easier to know what we're talking about. So that was a brief overview about the technical kind of pipeline of the tooling. Martin, do you want to talk about this slide?
Yeah, so thanks, Mikko. Thanks, Mikko. So,
may I have two questions to Mikko?
Sure. Yeah.
So, first of all, I think Holger did put a question into the chat asking why did you not use the license and copyright retrieval functionality of ORT?
Yeah. Can you elaborate a little what you mean with the kind of retrieval function? Do you mean, well...
Holger, perhaps you can clarify this a little bit more in detail? So Holger is currently typing. While he is typing, I want to ask you about, so, you know, SPDX documents can come along in different formats. So what kind of format did you use? RDF, tag value, or something like that?
JSON and YAML. They've been kind of, I found them the easiest to serialize and deserialize. So
of course.
A lot easier than tag value, for example.
Okay, thank you.
It seems Holger is traveling, so perhaps Mikko, you can discuss a bit around that, around his question.
Yeah. Now I see. And so basically, if I understand correctly, we could use this use Scango. Yeah. So the problem here is that Yocto has this kind of quite intricate patching system. So it's very hard, or there very often is not a source repository or source archive that exists on the internet that corresponds with the source that is built, because Yocto has these built-in patches, which are maybe Git patches that are during the build added to that kind of repository. So that kind of, if we want to analyze the correct source, then we would need to have some sort of functionality to actually add those patches during the scanner or downloader phase, and that we haven't really thought of how to do that the best. But yeah, that's the kind of reason why I think, or we think, that the analyzer part of ORT may not be that suitable for Yocto, because they're just nowhere it does exist the source archives or source code directly that corresponds with the packages. Does that answer your question, Holger?
To comment a little bit while Holger types there, we've earlier found also that it is difficult to use OSS review toolkit in embedded Linux scenarios, which most often just have this same problem or same situation where there is no package repositories available, as well as in some other technologies. Is there some other?
Well, while Holger is typing, kind of the data format question is interesting to me, because I really have tried some things with, for example, the tag value format, but it's very hard. So how are people divided? Do people use? I've seen the tag value quite a lot, and RDF a lot, and maybe JSON and YAML a little bit less. But is there some kind of, what's the gut feeling about people using different formats? Yeah.
So I can answer to Holger on Holger's what he just wrote about fossology. Holger writes that fossology is not different to scan code, and in his understanding, and both rely on source code. And in a way, why are we using fossology? I think the reason why we are using fossology is that we are relying on the REST API of fossology in a way that once we've done the source code determination and done those so that they are human verified, we can, for example, in this proof of concept case, we are now working in one project, but the client has many Yocto instances, and we can really reuse the same human curations based on the source file hash all over, both in the same Yocto product when it goes further and it gets new features and new elements, and then in all other Yocto projects that the client has. And then non-Yocto project has many of the same Linux core files, so we can, in a way, that was the Fossology in a way becomes a permanent database for the human verified license results there, and that's the one of the reasons that we at least thought that this is a way where we could more effectively reuse the human work across the lifetime of a project and across different projects.
Yeah, and from a more technical side, kind of the retrieval of source code. There are, of course, people here that can absolutely correct me if I'm wrong, but the ORT works in this very kind of independently modular way. So the analyzer can work independently, and then the only kind of thing that you need to pass to the next step is the ORT result file, which includes the download locations for the corresponding source file for packages. But for Yocto, there is no download location for this source file because it's patched during the build with this process. So that's kind of the problem with. So we could not build an analyzer result from Yocto build that then could be passed down the downloader or scanner, and the downloader or scanner would then download the source code because the source code needs to be patched during the build. So that's kind of my biggest thing why I think why we ended up using this sort of kind of non-independent way that the kind of it's modular, but it's not independent in so that we upload the source code for the build, and that is it. So the later steps don't need to do that anymore.
So there is Thomas asks that do we need something like curations based on file hash? And yes, that is something we use. That's the Fossology step, and also the double open stepping here is modular. So if we had some other source for receiving the license curations based on file hash, that could be substituted. The Fossology could be removed, and we could have something else instead. So that is what we currently use the Fossology, but it's just a convenience choice for now.
Yeah, and it's also kind of because. Well, the file hash based curations, what we do in Fossology, I think they're quite powerful in creating different versions of different packages, because currently, while working with ORT, we have to, if some dependency is, the version of some dependency is incremented, then kind of targeting the most of the files stay the same, and then the license information in them stays the same, and then kind of the hash value based curations may help target other versions better. So that's something that I think is powerful with hash based curations independent of be it Yocto or kind of general ORT. So that's something that I think could be useful.
I have a question to you, Mikko, because I'm not that familiar with Yocto. But what I learned up to now is that you are using this setup in order to cope with the problem that patches are included on the fly, more or less. Yeah? Would it also be possible to configure Yocto somehow not to let's say, grab patches from sources, or is this a built-in feature of Yocto?
Well, Yocto is built around these recipes, so let's use Bash as example program. So the recipe for Bash may be like, hey, the source for Bash version 3.2 or whatever is in this location. So we start this building the batch for our Linux image. We download the source from there. Then we apply these patches, which may be included in kind of the Yocto core. Some Git patches, they are applied because we think they're better, or that they fix some CVEs that haven't been fixed in the upstream yet. So of course that's configurable, but we need to take them into account if we want to kind of analyze the correct source. Of course, we could get pretty close by only kind of analyzing the beginning or the kind of the first source location, so bash 3.2 source, but then it would not be exactly what is actually built, because it would not include the kind of added stuff from during the Yocto build. But it's very, very Yocto doesn't really hold hand that much with kind of the patching or kind of retrieving of the source code part. It's very configurable. You can do basically anything you want there, but that seems to be the convention, to download source code from somewhere and then do some apply some patches and do some configuration steps.
Cool, thank you.
Okay, so a few other aspects here. Mikko talked about how the tooling works. I thought about a little bit discussing the approach in general, that we didn't approach this by, in a way, creating a tool. Rather, we approached this trying to, in a way, solve a business compliance need. And the perspective here is that we were looking at, we knew from our own history that there is a lot of it's more troublesome doing compliance on embedded Linux than on other areas, and the automation tools work a little bit less. We did a market research 2 years back and did find that, for example, Yocto is a reasonably popular embedded Linux. Build system is perhaps a little bit, how to do your own flavor of Linux. And then Jenkins is another popular tool. We did find a proof of concept willing partner with whom we have then worked. How do we solve their, in a way, business compliance needs? And basically the requirements we set to solve were to create a software bill of materials that's as detailed as possible, to get to reduce the work, currently too much manual work creating with the notices, get the compliance and the compliance alerts when compliance not in place, get those automatically, get a compliance artifact, and then also to enable the vulnerability tracking. We originally did have an exclusion that we don't go into the vulnerability space, but it seemed to be such a strong requirement from this and also other cases. So we decided to, in a way, work somewhat in that direction to enable the vulnerability tracking. And then there were a number of other nice to haves that for example, one is in a way to automatically determine static linking of proprietary files to copyleft licensed open source files. Those are then in a way nice to have there, and then obviously the objective was to automate as much as possible and minimize manual work and also increase quality. And one key element was that, which we defined, that what should be possible, focus on what is being actually shipped, what's getting out from the company, not focus on the open source packages, but rather focus on what is being shipped, because we knew from our Linux embedded work earlier, and also many of our other contacts know that in the embedded Linux world, the open source packages, they carry very much stuff, and not all is being shipped. Only sometimes only a few % is being shipped, and most often there are like problematic areas in test and build and other folders that that trigger all types of alerts, and when you start investigating that, you find out that, well, this is not actually being shipped. So if we could know automatically what is being shipped, well, that would help our compliance work. And then using the tools, the existing tools, and really here what Shane said, the SPDX and the interoperability layer here, I think at the core what we are doing here, we are using SPDX as the core interoperability layer here. We take an empty SPDX and then we, in a way, philosophically an empty SPDX, and then the Yocto meta layer puts into what is actually being shipped. The SPDX has also information on what was not being shipped, but it has also the information, well, these were the actual binaries, these were the actual packages that were shipped, these were the binaries that were contained in those shipped packages, and these were the source files that were in those shipped binaries. And that's one key element here, and in a way using the SPDX to get that information out of there and store it and be able to process it with any tool you want. And then I think that's pretty much what I have to say here. Mikko already explained how these different steps then fit into this. So. And we are currently, this proof of concept is about Yocto. We can, as you see, we are using the SPDX there, that if we get similar information from some other embedded Linux, whether you use Ort Analyzer, if you are successful in it, I think it would be great, but we found it a difficult task. And that's why we created for Yocto, the Yocto meta layer. We a little bit had a discussion with a Yoki-based, that's another Yoki-based another Yocto, something similar to Yocto, but based on Fedora, not based on Debian. And it seems to be possible to generate similar information out of that. So you could get a similar, like, detailed SPDX reflecting the shipped image. So then, if that was possible, then, well, you could do all of these steps. Or then you could change some element there. For example, change fossology to scan code or scan code, and then have the curations in some sort of file, separate file, and then use it from there. But then, in order to do what Mikko explained, you would need to have like a way of determining whether the files has changed and whether I can use the curations and what's the, in a way, the granularity, how you check that. But we are currently using fossology because that has a database. It's a SHA-based database, and we can use that. So and we've been in a research project mode for Double Open for around 2 years. Now the research project unfortunately has ended, so we don't have the public funding part anymore. It was a half public, half private funded, the project. But what we are now looking at, that could we turn this into a business? And whether we could, and for that we don't know yet, and we don't know how that will turn out. But for that we are looking at possible proof of concept partners to try out, well, possibly so that if somebody is interested, try out based on our documentation, we could help them, or we could be more engaged, or in different ways, trying to gain feedback of this approach. But that's that's my part. So thank you.
Thank you, Martin. I have a question in regard to the let's say the delivery artifacts, because you have said you have done all the analysis on the real images which are going to be shipped. How do you then also create the source code bundle of those things which are shipped because, as I have learned, files may be patched during the build. So how do you then compile the correct and corresponding source code, which probably has to be delivered too?
Yeah, for that, Yocto includes this kind of functionality not related to us. So they have this file or source archival meta layer, which works just like kind of our double open meta layer. You add it to your build, and then Yocto, in addition to the image, it outputs the source code used.
Okay.
And then I'll add that for verifying the compliance of that particular source archive, we then have the SPDX that defines that, well, these were actually the shipped parts of those sources, and then we have the ORT outcome that then verifies that, well, against this rule set, this SPDX shipped files, they were compliant, or if they were not compliant, then it also alerts on that. But that's supposed to be solved by the time you get the final shipped image.
Mm-hmm. Thank you.
There was also a question that how are we thinking of enabling CP and CVE tracking? And so what the meta layer does, as I said, it saves the kind of CPE IDs of the packages built. Yocto has some built-in functionality to retrieve kind of correct-ish CVE IDs, and then we also set the already fixed CVEs that would not be shown by the version number, and then we currently don't have any tooling kind of that goes forward from that, but then we have in the SPDX we have the CPEs and already fixed CVEs, so it should be relatively straightforward to actually kind of query those from an API.
So yeah, and to add on that, we've been working with Verifa guys. They have this new open source framework called Bubbly. And they are the idea with this particular proof of concept we are using is that Bubbly has created in a way service that imports this SPDX data and then queries NIST's database. There are a couple of databases that it queries based on the CPEs and the VVEs that were already patched. But that's the using the very fast Bubbly approach is for that is one way that this particular proof of concept is testing.
I have a question to a topic Martin has mentioned before, but only a corner of the whole picture. He spoke about combining a GPL file with a proprietary file. But that is not a question on file base. We, with Yocto, we make not an application, we make a distribution. So the question is what part of this distribution are independent pieces according to license compliance, and what are derived works? Do you have some means to show this?
No, that's something that currently needs to be done manually. So we haven't really, because how Yocto works, it kind of independent or undependent of whether the package build is Linux kernel or whether it's your application code, then they're all treated the same. So they are packages as comes to Yocto. So kind of that's something that we have to unfortunately list manually. So these it can be done either way. So whether you want to show what are your packages or your application code and only kind of work on those, and then or if you want to exclude some of the kind of kernel or the kind of non-application code from this.
So yeah, I like to add here that the good thing about using OSS review toolkit here is that it has a quite flexible rule mechanism, and with the SPDX we can with the SPDX that's recorded this way, and as Mikko explains, this has not been done, and it's something it's on a wish list, but we can see where into which packages and into which binaries each source file ended up with. And if you choose that you could choose in your ORT rule set that, well, for us, if it's in the same binary, it's always static linking, or for us, if it's in the same package, it's static linking, or whatever you choose is your layer of, in a way, how do you interpret that license requirement? How careful you want to be, and it's but anyhow, this in a way, as long as we track and we have a means of tracking, if you know what are your own files, for example, if you have in all your own files you have your proprietary copyright header, you can scan those, and then you can then you know that these files, well, if these files end up with a copyleft license in the same binary, make an alert, or if these end up in the same package, make an alert. And there you can also make a distinction between if it's a copyleft strong license, well, GPL for example, or if it's a copyleft LGPL license. We use this, LGPL has its own category because of its particular interaction mechanism there. So you could have a different rule in ORT for this, whether it's a copyleft LGPL and it's in the same binary, well, make an alert. But if it's a copyleft LGPL and it's in a separate binary, well, then it's okay. Yeah, so this is not something we've done yet, but it is something I think that is definitely doable. Something that we have as a nice to have from this our proof of concept, current proof of concept user, and something we think is of valuable, further reducing in a way manual work and increasing the quality of the output. But you need still to do your own decision on what is your interpretation on the LGPL license or the GPL license.
One question. You have mentioned that you have worked with Verifar in order also in the context of this Bubbly. Do you have here a person to contact? Perhaps it might be interesting for all the others to learn more about Bubbly.
Yeah, I think we have mostly worked with Kalle or Jakob actually latest. What's Mikko your?
Yeah, Jakob has been latest contact person, I think. And I linked the tool or the GitHub for Bubbly to the chats if anyone's interested.
And Jakob, do you have his email address so that I can approach him?
Yeah, sure, I can send it to you.
Cool, great, thank you. Are there further questions to Mikko and Martin, because we still have 2 minutes? No, obviously not. Oh, Sami is typing. Okay.
Thanks, Sami.
Yes. So thank you very much. It was very interesting, Mikko and Martin. And of course, we will have your session in the afternoon again. So everybody is welcome to join the afternoon session too. I found it really interesting, and yeah, that was really great. So that's it. If there are no further things, by the way, for the all other business, I have currently scheduled the next meeting for 28th of August, which might be in the high holiday season. So if you want to skip the meeting on 28th of August, please drop me an email. I will check for the agenda and send as soon as I have an agenda compiled, send it around on the mailing list.
Thank you on my behalf also. See you all in the evening session.
Thank you, Mikko. Okay, great. Then have a nice day, and looking forward to talk to you in the evening session. Bye-bye.
Thank you. Bye.
Bye. Thank.